Okay, so again, just to in this chapter, just to simplify the slide there, you can see in the slide there, you find out this is our equation. Okay, this is our equation where G is input output image, F is input image, and F is the transformation function. And then we try to simplify this equation. Okay, since we only process only one particular pixel over here, which is fxy. Okay, if you talk about fxy, actually x here have a certain coordinate, xy over here actually is a certain coordinate that represent that coordinate represent the f. Okay, f now again, like I mentioned before, this is the intensity value of that particular pixel xy. Okay, so to simplify these equations in this chapter, okay, you can also express this thing as something like this. Okay, so in other words, S here over T over R here is similar to your G X Y equal to your transformation function of your F X Y, because here you can see that this one is the intensity value of certain pixel xy. So G over here is the intensity value after you apply a transformation function through this value, where the coordinate is still the same coordinate xy. So in other words, that's why you can simplify this equation. Instead of represent it in this way, you can also represent in this way. Okay, just changing some notation there, but the process is similar. So that's why you can see that now S and R here denote as your R over here is the intensity value of input image, and S over here is intensity value of output image after applying the transformation function T. Okay, so this is the process how you do in the in point processing. For example, if you want to process, this is first S, I'm sorry, this is the first R. I just said R1. So if you for this R1, if you apply the transformation function, now it will produce this S1. So if you process this one, I call it R2, then if you apply this transformation function, you produce this S2. So meaning that instead of express in this expression, it's more better to process to represent the equation in this way, because now if you talk about the point processing, what is meaning by point processing, now you can see that this transformation function is only process the one single input over here, one single input of R1 over here, process with the transformation function, and it produce this S1, and then it will process one pixel by pixel, meaning that it will process this one, obtain this one, you process this one, you obtain this one. So each and every R over here will be processed and produce each and every S over here. So that's why it's better to represent the equation in this way. Okay, so the reason also why we do in this way is because we want to map the transformation function. Okay, if you, for example, you can see in this graph over here. Okay, if you can see over here, before I talk about this, the type of point processing over here, you can see the graph here. This is your R and this is your S. Okay, the one that we draw in the middle here, the line over here, is called your transformation function. Okay, again, for the first, initially there's a three basic type of gray level transformation function, or in other words, there's a three type of T over here. T type of T, which is you can have a linear transformation function, you can have logarithmic transformation function, and you also can have a power law transformation function. So how it's look like this, all these three function. Of course, in linear you divide it into two, negative and identity. So this is the transformation function, identity and negative transformation function. Okay, I'm sorry, this is the negative transformation function. Okay, this one, and then this is the identity transformation function, and then you have a logarithmic, which is logarithmic divided into two, a log transformation function or inverse log. Okay, and then power law also you have two, a square root, which is this one, and this one is the nth power transformation function. Okay, so you can see that that we can categorize the transformation into three. And again, why we represent the equation in S and R is because we can draw the characteristic of transformation function by doing some mapping here between R and S. So now you can see the transformation function, meaning that any value over here, okay, by applying this line, then you get the S. Any R over here, you apply any transformation function over here, you get their corresponding S. Okay, and another things that you can see here, okay, before I forget here, you might confuse what is L. L is a intensity levels. Okay, intensity levels. So if you talk about intensity level resolution 8-bit per pixels, the level is equal to 256. Okay, so why 256? Because you can have numbers from 0 to 255. So if you total up 255 to 0, actually you have a intensity level of 256, which is equivalent or which is similar to the available color you have. Okay, intensity level is equal to the available color, meaning that if you have 256, then you have 256 available color. So of course, if you, this one is we write in general way. Okay, that's why if you talk about image which have intensity level resolution 8-bit per pixels, then you can have the range from 0 to, okay, 256 minus 1 is your 255, and then this one from 0 to 255. Again, like I said before, this one is only for intensity level resolution 8-bit per pixel. Okay, later you will see that in many example we have a lot of example later, and same goes to question, final or test question. We might reduce the intensity level resolution less than 8, because in term of we want you to, we ask you to do some hand calculation which is easy than 8-bit per pixel, because if you ask the things in 8-bit per pixel is very difficult and very time consuming for you to do hand calculation. That's why we try to make it reduce the intensity level resolution for just for the sake of it will make you easy to do hand calculation, and it make you possible to do your hand calculation in exam time. So that's why we try to do that. Okay, that's why in this formula over here we make it in general. You have L from 0 to L minus 1, because the intensity level you might have a different intensity level if you have an intensity level resolution, different intensity level resolution. Okay, for example, if 4-bit per pixels, the intensity level should be how much? 16, I think. Yeah, 16, because you can have number from 0 to 15. Okay, and how about 3-bit per pixels? Then the intensity level can be up to 8. Okay, because you can have number from 0 to 7. So the possible color you can have, or the available color for 3-bit per pixel is 8. Okay, that one is just some additional information for you, just to remind you that how actually and why actually we represent the graph in general way. We don't put 0 to 255, we put 0 to L minus 1, because later the intensity level resolution will be changed. Okay, now let's go to the negative linear transformation function. Okay, if you talk about this one, if you represent it, okay, negative is this one, sorry, this one. negative transformation function. But if you talk in terms of if you represent the transformation function in graph, but you can also represent the transformation in formula. Okay, if you talk about negative transformation function, this is the formula. Okay, so again S is equal to R, and then now because your T is negative transformation function, that's why the formula is L minus 1 minus R. Okay, forget about this one. Okay, L minus 1 minus R. So I think this is one of the simple transformation function which also apply in medical imaging, especially when you want to produce X-ray image. Okay, the one that you receive in the last the end product of your X-ray machine, or X-ray the X-ray image, the final X-ray image that have been produced by X-ray machine is in form of negative image. Okay, that's why you can see that the bone is white while the background is black. But actually before actually you obtain that one, actually it should be in other way around, meaning that it should be the bright part should be the background, and the dark part should be your bone, because bones have a high density, is a high density tissue where it absorbs every X-ray signal. So that's why you cannot see anything while the background, because you don't have any high density bone. That's why you can get almost all X-ray spectrum at the intensifier. So meaning that the background should be white and the bone should be black. But once it arrives to you, it's in other way around, meaning that now the bone is white and the background is black. That is because you are receiving a negative image, meaning that before you get that image, actually it has been processed by the negative image transformation function. So that's why this is the example. Okay, this is the one that received at the intensifier, but once it's arrived to you, okay, this one is the one have been received by intensifier. Okay, one is received by you, you will see this one. Okay, that is because you are receiving a negative image, meaning that the output image from the negative image transformation function have been received by you at the final part, because it's more easy to see if you can see the high density tissue like bone white while the rest is black, as compared to you have the black represent the bone while the background is white. Okay, so in other words, this is one of the common and simple approach that have been applied in your X-ray machine. Okay, now let's take a look of distinct pair and share activity number 2. Okay, given the following is a 4-bit. Okay, remember this is 4-bit, here is your intensity level resolution. Okay, so that's why your L now is equal to 16. You can have the color from 0 to 15. Okay, again, like I said, any question, try to extract the important keyword. Okay, this one is intensity level resolution, this one is a spatial resolution, 4x4. Even if we don't mention this one, you can see over here 1 2 3 4, so it's a 4x4 matrix. So given the following is a 4 bits 4x4 image, find the negative image. Okay, on the right. So you may use this formula. Okay, this formula. Okay, now, okay, before you go to the next video lecture, please do this activity. I have provided in your e-learnings, and this activity is a non-graded activity. Okay, but it will it will use as your proof of attendance. Thank you.